Hello, ma'am.
Yeah, hi. Good evening, everyone.
Good evening, ma'am.
Hello.
Hello. Am I audible?
Yes, ma'am.
Okay. So, have you gone through the last session, everyone? Till TLM port concepts. Any doubts till TLM ports? CB? And I
No,
think
ma'am.
most of you not attended for the last session. Vishal, Tamanna, Gurushant, Sampriti. Have you gone through the recorded session?
Last session I attended, ma'am. It was on
Okay.
Monday. Okay.
Yes. Okay. So in the last session, we have discussed one final topic. I have shown you one program for FIFO memory. So have you gone through that? Why do we use the dollar test augment system task?
Ma'am, by using that, what I understood was uh, we can override our count value inside our environment, ma'am. Actually, in that example, we are accessing that environment components, ma'am.
Okay. Mm. Okay. So we are accessing the environment components. Why? Because
Yeah,
test is the top level of environment. That's why we are calling the environment components in the test. Before that, we have declared the constraints here. Constraint 1 for write, constraint 2 for read, trans 1 and trans 2 for main test. Okay, three constraints we have taken. So these three constraints we need to do the randomization. We are taking three different transaction 1, transaction 2, transaction 3. Normally in system verilog, if you see in the previous sessions when we are learning system verilog, we didn't created any constraints like this. Like we create constraint 1, this constraint 2 in the same class and constraint 3 in the same class. Okay, so in this case we don't get any polymorphism concept here. Okay, but here we are considering two base classes. Trans 1 is one of the base class, that means one test case separately. Trans 2 another base class, another test case. Okay, so whenever we are taking these three separately without taking all these three constraints, if you take all these three constraints in the same class, we create only one transaction object. By using that one transaction object in the generator, we do only one time randomization, and in environment also we will create only one transaction, and in test also we run only one transaction. Is that correct?
yes, ma'am.
Others? Gurushant,
Can you repeat what you have?
what's your name?
Uh, Anil. Okay.
Okay, Anil. So if you remember system verilog test bench architecture, I will show you another system verilog test bench. Suppose here there is a transaction class. Okay, so in this transaction class there is a constraint. So this constraint we have written only in the same class, in the main class. Okay, so in the main constructor, I mean transaction class, even if there are multiple number of constraints, constraint 1, constraint 2, constraint 3, if you write in the this calc trans main transaction, we will create the object for this transaction in the generator, By using that object, we do the randomization, right? But here what happening? We are taking 3 classes. One is a parent class, trans1 is a child class, trans2 is a third child class, okay, or second child class. So total 3 classes is there. 3 classes are there. One is a parent class, 2 base classes. Okay. In parent class, we have created one constraint, this one. In base class, another constraint. In child 2, I mean base 2 class, another constraint. So total 3 constraints individually. Okay. Here we are having the polymorphism concept. So if you want to randomize this test, how we need to do randomization? In the generator, we need to create 3 number of transactions for 3 classes, 3 objects, right? So one TR is for base parent class, another T1 for child class, another T2 for child class. Okay, so 3 transactions we have created and 3 times we did the randomization. For write transaction, read transaction, and rand transaction 3 times. At the same time, in a test, so how we are calling in the test with environment TR, T1, T2. So here also we use this test like arguments $test plus argument system task and call the task, and here also 45 line. Okay, I have asked this question in the last session. So what is the use of this, and what limitations we are observing in the system Verilog test bench, and how we can avoid that limitation in the UVM test bench? So that's what my question. Can anyone?
In UVM, we use object overriding concepts and all, ma'am. So it is not available in system Verilog. So for that case, we are using this test plus args, ma'am, because when we use this, we can access. We have 3 different transactions with 3 different test cases. So, but we need to check all those 3. So for that purpose, in system Verilog, it is not similar to UVM. So if it is UVM, we can use object overriding concept and we can override our previous object with new one. So since it is not available, we are using this test.plus args. So when we call, for example, when we call T2 in generator, where we use T2, it directly goes there, ma'am. For example, we use e.run1 for T2. T3 we use e.run1, run2, like that. We have different functions, methods and all. So when it comes to that case, we can verify our objects, ma'am.
Okay. You have completed all UVM recorded sessions, huh?
Yes, ma'am.
Okay. How many of you still there to complete all UVM sessions? We already discussed this topic in that session.
Actually, I'm also not that much clear, ma'am, but I can understand this, but I can't explain it clearly, but I can understand somehow.
Fine, no problem. So you are telling here we can do the override. Okay, so how we can do the override? First of all, what is the basic step to override?
Yeah, when we go to the transaction, we have 3 different classes. So that 3 different class have 3 different test cases. So we need to test all those 3, but
What
it is
method
not possible.
Okay, wait, no need of all that thing. What method we use to do overriding?
Where in UVM or in system here?
In UVM.
Virtual.
Set type
Virtual
override.
method.
Virtual
What is the
class method.
difference? No. What is the difference between new and create?
Yeah. We can override when we use create. We can override, but we use new. We can't do that.
Okay, wait. Any other? What is the difference between new and create?
New is to construct an object, just to construct an object. While with the create, we construct an object we using factory method.
Okay. Then
Yeah.
what are the still any advantages with create method?
Yeah, using factory registration, that object can be it can be reused and can be overridden.
Okay. Okay, fine. So actually by using a new method in system verilog, we can change dynamically, but we cannot we override any data type by using a new method, and also we cannot change at a runtime. Okay, by using the create method, we can override the data type or any base class name by using the factory registration concept. We use for that purpose, we use a create method. Okay, so basically in system verilog, wherever you see, we use only new method to create a transaction. Okay, to create a object, to create a mailbox, whatever, we use a new method like this. But in UVM, we never use a new method to create any object or class. For class constructor, we use a new method, but for instance creation and object creation, we use a create method where the overriding is possible, and also we can change the data in a runtime. Okay, so coming to these these three test cases here. Constraint 1, constraint 2, constraint 3. First of all, what is the need of taking these three constraints? Why don't we take only one constraint in whole test case, in whole test bench? Means, suppose if you take only one constraint, whenever we are doing a debug or in the coverage analysis, it is difficult to hit all type of bins in the coverage. Why? Because in coverage we will take lots of bins, right? The lakhs of bins will be taken. So to hit the lakhs of bins, if there is only one test case, it is difficult to hit all. Okay, so for that purpose, we create multiple number of scenarios, multiple number of test cases, or multiple number of constraints. So in that case, at least one test case can hit 50,000 bins, another test will hit some more 50,000 bins, and next test can hit some more bins. So by using these type of packets like right transaction, small transaction, big transaction, or these type of transactions, we can hit more number of bins, and also all corner case scenarios will be covered. Okay, but in system verilog, we are finding this type of limitations. Okay, so every time the overriding is not possible, every time we need to create the object assignment statements. If you see here generator, actually in generator we create only one time randomization, but here we have created three times for transaction TR, and for transaction TR T2, and for third transaction T3. Three number of transactions we have created. Every time we assign the object separately. Okay, that is the main disadvantage with the system verilog. If there are thousands of test cases or constraints, we need to create thousand number of times. Okay, so to avoid that limitation, we use the UVM factory concept. Okay, so first of all, what is meant by UVM factory? What is the necessity of UVM factory? In the sense, if you are working with any transactions like write transaction, read transaction, like a big transaction, to cover all the scenarios and to improve the coverage, we need to use some transactions like this. Okay, so in system verilog, whatever we are facing this type of problem, like handle assignment in case of generator. So whatever the generator we are looking here, to avoid this handle assignment every time, the generators will be configured with a different type of transactions. Okay, so then what about the other components? Okay, generator side we have created three number of transactions. Okay, but driver side, every time we cannot create three number of transactions. If you see, if you observe driver side, we can we can pass only basic transaction only, not transaction 1, transaction 2 we cannot send. Okay, in driver side we can send only basic transaction, At receiver side also we can send only basic transaction. Scoreboard side also we can send only basic transaction. But only in the generator we are able to create 3 different transactions. But at final value we are not able to send all the 3 transactions. So here by using a test dollar plus argument we are able to pass one by one test case, that too in a hard coded. Hard coded means not automatically, we are calling every test separately. Okay, so here one test we are calling first, calling the main task and also test task, running reset task, everything from driver and main generator and tester. And then again creating the second one here. In the second one also calling the generator dot count value, driver dot reset value, and the main task. And in T3 also calling everything we are doing hard coded. It's not automatic. Okay, so for that purpose, to avoid this limitation, we use the factory registration concept. Okay, so by using factory concept with the use of single instruction, we can change the data types of all the transactions in multiple components. Whatever the components are there, everywhere we change all the transactions. Okay, so in that way, overriding of data type is possible using single instruction with the help of factory. If there is no factory, it is difficult to change the data type. We may need to write multiple object assignments same way in the generator. Okay, so by using a single factory statement, we can do the multiple assignment statement. In that case, you no need to write all these things, dollar test, dollar plus arguments, no need to write all these things. Okay, suppose if I explain here, did you understood? Or I will explain once more clearly. Suppose there is a T1 here. Okay. So this is test case 1 in system Verilog. It directly build the environment components and run the environment component, so that all environment component working with this base transaction will run. So if you see here, e dot build, nothing but e is the environment instance. Okay. So e dot build, e dot g count, e dot d dot reset, everything will be running from environment with base transaction. That is what base transaction. T2. So this T2 is a test case 2. So the object of this generator pointing to the another type of transaction. If you see here, T2 is a object here. It is pointing to the another type of transaction, polymorphism concept. This is what object assignment I'm telling, right? We need to do multiple number of times object assignment, the polymorphism concept. T2 is assigning to TR. Okay. So in this time also, after that, if you run the environment component, please mute your system. Generator is working with the second type of transaction. Okay. In third case, in third transaction here, TR equal to T1, the generator of transaction is pointing out to the third transaction here. In that way, we can make sure that the generators are generating different type of transaction in each test case. Okay, the remaining components, monitor, driver, scoreboard, working with the base transaction only. Everywhere if you observe, we will have only base transaction TR. And here in receiver also, we will have the base transaction TR. And scoreboard also we have the base transaction TR, not multiple transactions. Okay. So even polymorphism helps here, but not the proper solution. Okay, because in another component still we are making some right transactions and second type of transaction is not working, third type of transaction is also not working. So if you want to change the data types of multiple components, we need to write the several object assignment statements, however we use in the generator here. Okay, so in order to avoid that, we use the UVM factory concept. Clear everyone till here?
Yes, ma'am.
Others? Sampriti, is it clear?
Yes, ma'am.
Vinita, Gurshant, Vishal, Uma? Okay, fine. Okay, let me know if you have any doubts. Okay, so now UVM factory. How do we write the factory concept first of all? UVM factory concept. Okay, it's a simple thing. You already know how to write the UVM factory concept. How do we use the macros, object util macros and component util macros? But that is a basic thing. We need to know in detail about the purpose of UVM factory mechanism first of all. Okay, so what is the purpose? Before that, we will discuss what is a UVM factory. So it is a class. First of all, UVM factory, we write within a class using the create method, using the components object during the runtime. So if you see here, class UVM object utils, you already know sequence, sequencer, sequence and sequence items are the objects in UVM, and sequencer, driver, monitor, scoreboard, all these are components. So however we write here macro UVM component utils or object utils, that's how we create the component using the factory registration concept. Okay, so in system Verilog, did we created and allocated the memory to the components by using the create method? We just use the class constructor, right? So here in the generator, we just use the class constructor, this one, function new constructor mailbox. If you go with the driver, we use this function new constructor, and here in receiver, we use the function new constructor, and in the scoreboard, we use this function new constructor to create the class. Okay, so in system Verilog. But in case of methodology in UVM, we can make use of the factory. Factory will do all these things. Just if you write a component util single macro, this line will be replaced with that constructor. Okay, so along with the creation of this factory, it had the ability to modify. We can replace any transaction with any transaction. Like suppose you have created three transactions: write transaction, read transaction, and main transaction. So now by using this factory concept, you can easily replace write transaction with a read transaction, and replace with read transaction and write transaction, or any other transaction. Suppose there are two transactions, APB, AHB. AHB transaction you want to replace with APB, then you can easily do with this factory registration concept. Okay, replace is possible, overriding is also possible. Okay, so in order to make use of this factory, we need to follow some steps. Okay, what is the first step? You need to register a class with this factory UVM component utils, creating the component and object using the new method. So here sequencer suppose. So we need to use the class constructor. We need to create the component, and we need to override the component and object. So how we can override the component and object, we will see that thing. Everyone understood till here?
Yes. So
Any
first
doubts
step
till
is,
here?
so first step is to register the class, right? Like UVM
Mhm.
component utils. And second
Yes,
step is using the constructor new.
constructor. Yes.
Okay.
Third step is overriding. If you want to override based on that, how we can override the data. So for overriding, we have lot of methods. We will discuss one by one. For factory concept, we will discuss in 2 days. Okay, in single day, you can't understand all the concepts. So we will discuss in 2 days slowly. So first of all, main thing, what are the purpose of factory registration? First of all, first one is dynamic object creation. We can create dynamically. Dynamic object creation using UVM factory. So how can we create this dynamic factory registration? Here, writing test cases are very important. Okay. So whenever you are writing some test case, try to remember the syntax. That is very important. Okay. So how we can create the factory? First of all, how can we create the object dynamically? By using the create method. In system Verilog, we just create using the new method. So here generator is there, class generator, and created the function generator. And for here generator, we just create as a gen in environment. So here in environment, we just create gen g, and for the g you just need to put new method. Okay, but in UVM it's not like that. We need to create class base transaction, which is extend from, always base transactions will extend from which transaction?
UVM sequence item.
item. So UVM sequence item is the library. Here you need to write the object. So I'm just copying from here. UVM object utils. What we need to pass here? What is the class name? We need to pass the class name. So class name is the base transaction. So
Base
pass
transaction.
the class name here. So this is what we call as a factory registration. Okay, next, create the constructor. I'm copying the constructor from here. So what is the base name here? You need to pass this again, transaction name, class name. Function new, string name, base transaction, super dot new equal to name, because we need to access from the parent class and function. Okay, next, end class. In outside the class, in top level tester, or next any other module. Suppose I'm considering a module test bench. So here how do we write initial, begin, need to create the object for base transaction. So class name is the base transaction, object txn. Okay, so how we can create this object using the factory? Create object using factory. So how we can create transaction txn is equal to name of the class, base transaction, scope resolution operator, type ID, means data type. By default, need to use the create method. This is what the create. Create, what we need to pass, name of the transaction, txn is the name of the transaction. This is what the syntax to create the factory object. Okay, so now you can write any statement, like if transaction is equal to some 0 or 10, whatever, successfully created the object, else failed to create the object. It totally depends on your any statement. Transaction is equal to null, suppose is not equal to null, then what we can say? $display successfully created the transaction, else unsuccessful. I'm just writing like this, but you need to write in a display statements. Okay, end module. So this is how we can create a factory registration and also base class. I mean object creation. Clear everyone? First one, dynamic object creation using factory.
Yes, ma'am.
Next, how we can do the override. Another advantage of factory is a overriding concept, because here we are not able to do the overriding for this transaction 1, transaction 2. Every time we are doing hardcore values and also polymorphism. These all are polymorphism only. TR equal to T2 and here also TR equal to T1. Handle assignment. Every time we are doing handle assignment. Okay. But by using factory registration, we can do the override. Why we need to do override? Suppose in a SOC, there is a system on chip, and here APB protocol or APB agent, AHB agent, AXI agent, PCIe agent. 4 type of agents are there. Okay, so in APB agent we have APB sequences, and AHB agent we have AHB sequences and AXI sequences. Okay, sometimes maybe this AXI we want to replace with the AHB. Okay, so if you want to replace with the AHB, how we can replace? Everywhere, wherever we use AHB, same we need to write generator, we need to create driver, we need to create monitor, scoreboard, inside the constraints, everything we need to change. We cannot override directly. Okay, but suppose if I use the factory concept, just you need to write like factory set override, syntax will be there. Just by using this APB transaction or just using AXI transaction, you can replace AHB transaction very easily. Okay, so I will show you how to write the syntax for that. So first purpose is dynamic object creation. Second purpose is factory overriding. Everyone understood the concept? Why do we do why we need to do the overriding? We can override a base class with a derived class without modifying any test bench code. Without modifying the test bench code. So how to do that? First of all, suppose I am creating AHB transaction. Okay, class AHB transaction. Extends UVM sequence item. And next, object utils AXI transaction. So same I'm taking here. And also function new whole class I'm considering. Function new whole class. So here change this name to AHB transaction, and here also change the name to AHB transaction. So I have created one AHB transaction and creating AXI transaction also. AXI and here AXI. So 2 classes we have. Okay, now it's a in the outside the class, in the main test, create the test. UVM factory. By default, we have a method library UVM factory. Just take the name of the factory. I'm just taking the name of the factory as a factory. Okay. Then UVM factory get method. We need to get the default library methods from UVM factory. Okay. Now factory name, UVM factory name dot set type override by type. This is what the syntax. Okay. So everyone must remember set type override. I will give you the PPT after the session. I will share you the PPT. I think I already shared the PPT. So there you will find all the syntaxes. Okay, set type override by type. So what is the base transaction here? AHB transaction. Give the AHB transaction here. Which one you are going to override? Get type. Get type, comma. Next, what is the AXI transaction? Okay, so this is how we can override the transaction class. Now, for a AHB transaction, create a transaction. How can we create the transaction? Same here. Transaction base TX ID. But here, not base transaction, it's a AHB transaction here. Type ID create TXN. Okay, so object created. You just write a statement like a dollar display statement, whatever. Object got created. And finally, you need to do some project on this. Okay, remember all the concepts. So this is how we can do the factory overriding. So what will be the output now? Whenever you are calling this AXI transaction, instead of this AXI transaction, all AHB transactions get allocated. Okay, because here we are overriding the AHB transaction with the AXI.
One question, Prashanti.
Yeah, tell.
So here, when we are creating object transaction here in the test bench, module test bench, so we are overriding AHB transaction with the AXI, right? So then that object creation is for the AHB only? I mean,
Here we are just requesting the test bench for AHB transaction. It actually creates the AXI transaction because it override the factory. We have created for base, I mean AHB, but it will override with the AXI because we are putting AHB to AXI.
okay. So we
Before
need to create
we
for
did
the base class only.
AHB, AXI, allocating AHB to AXI. This is what polymorphism concept in system verilog. If you see in generator, here TR equal to T2. What is the T2 here?
Child class object.
T2 is the present whatever the task we are considering for T2 transaction, whatever we are randomizing, we are assigning to base. Okay, here we are using polymorphism. Same here also I did AXI we are assigning to AHB. Now output will be AXI only. It replacing AHB. So output will get AXI. Whatever the transaction data or handles, whatever, total AXI transactions will be assigned to AHB. But we are not modifying any test bench code here. Actual test bench code we are not modifying, just adding extra piece of code using factory registration.
Okay.
Okay,
So,
that's
but
what we call.
yeah, so, but we need to create a object of base class only, then automatically by set type override, output will be of the AXI, I mean
Itself
child
will
class.
be assigned. Yes. Factory dot set type override by type AXI transaction get type dot whatever the right hand side is there, that right hand side data will be assigned to the left hand side data. Suppose if you put interchange, here I am putting AXI and right hand side I put AHB, then AHB data will be assigned to AXI. Okay.
Yeah.
In that case, what will be happen? AXI is equal to AHB. So output will be AHB. Here we need to create the AXI only.
Yeah.
Okay.
Thank you.
Syntaxes are important here. So that is what second one. Second one in the sense importance of factory registration. So that is what second purpose of factory registration. Clear everyone?
Yes, ma'am.
Next, what is the third purpose? Third purpose of factory is avoiding the hot coding. Hot coding in the sense whatever we are using here, test argument, this dollar test dollar plus argument system task, we need to avoid this. Okay, so if you see here, every time we are calling individually. So first T1 we called and T2 called and T3 called. So even those are the transactions, not objects. It's these are the transactions from I mean those are the objects from main class. Okay, transaction is the main class. To this transaction T1, T2, T3 or T1, T2, these are the objects. Okay, so in these objects, how we can override, how we can call automatically without calling hot code. Okay, we need to avoid the hot code values here. Directly we need to create the transaction 1, 2, 3 without using this plus argument, test arguments and all. Okay, so how we can do that? Third one. Avoid hot coding. That means no need to use dollar test dollar plus argument. Okay, without using this, just create a class same here. However, I have created the base class function new and just creating that. UVM sequence item. Extends UVM sequence item created the class. Okay. Now how we can create the number of transactions. Normally we create in the generator. These things you can use in the generator. So what is the class name? Base transaction T1, T2. Okay, so how we can create T1, T2? Same here. T1 base transaction create T1. Did you all got the syntaxes for phases, TLM ports? Have you practiced? T2. Today I will share you some problem statements, assignments. So try to write the program for that. So you will be getting understand. Okay. So this is how we create the transaction 1 and transaction 2. Dollar display created first transaction and dollar display created second transactions. So in this case, we can avoid taking the hard coded values. But what is hard code values in real time? Like, how can we avoid writing the hard code values? What is the approach? Is there any other approach like overriding the transaction class? Mostly we will consider in this way only. Okay. Any other doubts still here, everyone?
What is the first advantage of using create?
First advantage of using create. See, what we did here, overriding. That means AHB transaction overridden with AXI transaction. If you use a new method here, you cannot do override for this. We have two type of override concepts in factory overriding. Type overrider, instance overrider. Global override we can also call as type override, and also instance override. We will discuss that thing once you will get all these things. So there you will understand what is the importance of create method.
Yes, ma'am.
Okay. Any other doubts still here?
Ma'am, you mentioned two types of overrides. What it is? Instance override and
Type override.
type
Type
override.
override.
Okay.
Global
Okay.
override we can also call. So what is the difference between type override and instance override? Any idea
So
from others?
the one that you shared just now, where you wanted to
Type
override the
override.
HB, it was global override, right?
Yeah, whatever we used here, set type override by
Mm.
type, right? That's
Mm.
what global override. Instance override means particularly instances. Instances means here T1, T2 or the instances. For that we use set inst override type by type. That's what we call as a instance override. Okay. So better we will discuss that thing overriding tomorrow. As of now, everyone get clarity with the registration concept, factory registration. Or else if you want to discuss today, I can complete today only. Object overriding. Hello. So finally, we will create two, suppose here FIFO UVM test bench is there. We will try to create AHB test bench, simple test bench, just to know more clarity about the registration. Okay. Or else even suppose there is a FIFO, I already given adder example in UVM, right? So how you can use the factory registration here in a transaction class, and how you can convert this transaction data to adder. So how you can override the transaction data to adder. How can you do that? Okay. Okay, let me write one piece of code. Tell me what will be the output. Okay. maybe you will get some more clarity. Suppose I'm writing a class. My transactions extends UVM sequence item. Okay, so here create a function and class. And I'm creating a object manually. Whatever I told, like a hot coded. Okay, so how can I create like my transaction T1 equal to new. I have written in the test bench, suppose. Okay, so like if you want to replace my transaction with a new transaction, you must manually update the test code here. Okay, but by using the factory concept, how we can do that?
By registering my transaction with UVM object utils, and then we can use set type override by type.
Okay, any other answers? Others? I asked the question clearly. I want to replace my transaction, or I want to override my transaction with the new transaction. For that purpose, what I need to do? Step by step. Nearly 4 steps will be there here. What will be the step 1? Fast. Sampriti, Sheetal, Vinita, Sandeep, Vishal, Gurshant. Remaining. What is the step 1?
You probably need to create the object T1 rather than newing it.
Creating the object. Okay, how can we create the object?
TQVM object utils.
So this is wrong.
Yes.
This new, we need to remove this new. So after removing this, okay, first we need to write the object utils. So UVM object. Why only object? Can't we use component utils?
UVM sequence
Oh.
item. Yeah.
Okay,
Correct.
because of UVM sequence item is an object, so we need to use the object utils only. If it is a driver or a monitor, scoreboard, whatever sequencer, we need to use the component utils. Okay, I think everyone clear till there. Okay, then I told we need to replace my transaction with a new transaction. So for that purpose, we need to create the new transaction class also, right? So I'm creating, instead of my transaction, new transaction. So here also new, and here also new. Here mine. Okay, next what we need to do? Next what we need to do?
Create the object by using create.
Create the object. Okay, how can we create the object?
So we will create the object by type by create method.
Type ID. Yes. You can say as a type ID or a create method. So already here instantiation completed. So create the object. So T1 is equal to, what is the syntax?
My
My
transaction,
transaction,
scope resolution, type ID, scope resolution. Create.
type ID. Okay. Create. Need to pass
T1.
the transaction instance T1. Okay. If there are multiple number of transactions, you can create multiple T1, T2, T3. Okay. So how can we override now my transaction with a new transaction?
By using UVM factory, what we have done in the AHB ones, right? Like
Tell me the syntax.
UVM factory,
UVM factory.
factory
Set type
Set
override.
type
override by type.
override by type.
Right.
My
My
transaction.
transaction.
Okay.
Get type, scope resolution.
Get type.
Comma, in what we have want to
New
override.
transaction.
Yeah, new.
T1.
Get type.
Get
These
type.
are permanent, like default syntaxes. Okay. So now to the my transaction,
One doubt.
new transaction will be get assigned. Yeah, tell.
Ma'am, after UVM factory scope resolution, don't we have get method?
Here we don't use a get method, only set, because we are not using any config db files like that. How can you get the data? Are you taking any instances to use a get method? Mostly we use get method, set method in a config db, because somewhere we put some data in the file and we need to get the data. So set the data, get the data, or put the data, get the data. But here in UVM factory, we are just overriding. So what is the use of put?
Yeah, that I got it, ma'am. Like set type override is the syntax keyword. What I'm telling is before that, after the scope resolution, get then function dot there's it. That is not the syntax. Means
No.
earlier slide you showed you're creating one variable for UVM factory, then
Okay.
in next.
Okay. Yeah. That is what we need to put. Just created the here UVM factory and then setting the data. Yeah. You need to put this. By using, if you create the factory name, then only we can use the factory name here, right? So you need to put this.
Yeah.
Okay. So we need to put the data, get and set. Okay. Suppose if I am doing same thing for instance overriding, I told that in override we have two types. One is object of overriding, class overriding, or global overriding, or type overriding. We can tell anything. If you want to do instance overriding, suppose T1 is there. In polymorphism concept, here in this FIFO, in the generator here, we did TR equal to T2. Okay, to TR and T2 both are instances only. And here TR equal to T1, both are instances. Okay, same way here I'm creating another transaction T2. So, comma T2. Here also T2. Now I want to override T1 equal to T2. So how can I override? By using factory concept, instance overriding. Before I told you the syntax also, while I am explaining to someone. Did you remember? Set instance. We need to, instead of set type override type ID, we need to use a set instance override by type. Okay, okay, no problem. Practice till here, till factory registration. Tomorrow session we will work on some overriding and remaining topics. Okay. And any other doubts from UVM phases or TLM ports? Any doubts there? Hello.
No, ma'am.
So actually, you said 4 steps, right? So one is creating the object, then I mean
Where here?
yeah, you
For this
while doing
problem
the
statement.
overriding, you said there are 4 steps. So
Mm.
first step is obviously creating the object,
Okay.
like line 125. Is that the first step, or
Yeah,
120?
first of all, factory registration, creation, dynamic creation, object utils, that's one first. Next, overriding the component, so creating the component new transaction, next one. And how to write the override here, this set method. And finally is sequence, creating the base sequence.
Sorry, what is the final step you said?
This one. First, we need to create the sequence transaction, and then we need to use the set overrider. These are the steps.
Okay, sure.
Okay. So suppose if I use
So this is global overriding. We didn't discuss
global
the
override,
instance overriding today.
instance override, we will discuss. Instance override also same like this only. Here whatever I kept factory T2. T2 is anything. I need to write UVM factory. Get set method. Here only we will create a both get and set. Set inst override by type. So which one we are going to override and which one? suppose T1. So T1 get type and overriding with the T2. Get type. Comma. Here we can write if you want to get full name of that transaction. Like that you can pass get full name. That is just extra. If you want to put, we can read. This is what the syntax for instance override. Okay, so whatever we created T1, T2 here, after this create those two. This will be the default and second one will be the overridden. Okay. Clear everyone? By using the get full name path, we need to provide the instance name path. So which one you are going to use? Override. We will discuss tomorrow these things more clearly with some more examples. So from first step onwards, is it clear, everyone? So in PPT, I have mentioned in UVM factory, non-parameterized and parameterized. So what are the parameterized classes in UVM? Even if there are no
Sequence.
parameterized classes, you can use param utils. So if these are parameterized classes, then you need to use object UVM object param utils. So here you are passing some any type ID like integer data type or with the data whatever. So we need to use these param utils for parameterized objects. And non-parameterized component. For component, we need to use the macro UVM component utils, and for parameterized components, tick UVM component param utils. This is how we do the registration, factory registration. So what is the importance of factory registration? Not only overriding, you can access the methods, copy, compare, clone, do hook methods are there. So and also you can able to access the verbosity levels, UVM medium, UVM high, UVM low. These verbosity levels are there, right? So at the starting day I told these all these things you can utilize by using the factory registration. If you don't return these UVM component utils or object utils, you cannot utilize these things. So that's why tomorrow session we will discuss on more into the instance of override and some more problem statements with global override and config db files. Okay.
Shanti, in one last purpose you have told of the factory registration is a hard to avoid the hard coding. So by any example, like that is bit not clear for me, like how we are avoiding hard coding.
Hardcore values in the sense like this in the test. So how we are writing here directly we are passing this T1 T2 by using the $test plus arguments. These are nothing but hardcore values. one by one. Each one we are calling separately, T1, T2, T3, everything we are calling. So if there are 100 number of transactions, we need to use 100 number of times this $test plus argument. Okay, so without using this, we are directly using the factory concept here. So
Yeah.
that is how we avoid the test plus argument. Directly we create the T1, T2. If you create like this, directly it allocate separate assignment, handle assignment to each one. We no need to assign like this polymorphism concept. In generator, we have polymorphism concept, TR equal to T2 and T2 TR equal to T1. We no need to assign these things. That too, what is the main drawback here? By if you take multiple transactions in driver, receiver and scoreboard, those T1, T2 are not reflecting. In generator, however, we took handle assignment statements, till there only these are working fine. In driver, receiver, actually TR, T1, T2, these three transactions, driver need to drive the data to the DUT, but here driver can able to pass the data only of TR, only for TR data, not T1, T2. In the same way, receiver cannot get the data of T1 and T2. It can receive only T2 data. Okay, at scoreboard also same. But generator side, we are passing T1, T2, T3. I mean TR, T1, T2. Okay, so here we are getting loss of data. If you want to pass all these three, we are using this $test plus argument T1. These are hard coded. That's what we are telling. Separately, we are calling. Without using all these things, simply in factory registration, we are creating T1, T2. 2 lines enough.
Okay. And if there are more number of objects, except like, for example, from T1 to T10 or
Every
so,
object we need to create.
we need to
Every
create.
object we need to use
Oh,
the create method.
create
And also,
method.
if you see here in the in transaction class, sequence item extends UVM sequence item. In transaction class, whatever the data in write enable, read enable, empty, full, reset, data out, all these are there. You need to register all the fields. Those we call as a field in transaction item, sequence items we call. So main class you need to register with the object utils. Remaining fields you need to register with the UVM field int macro. These are important. Okay, without these you cannot access the copy methods or compare, clone, all these methods you cannot access.
Yeah, okay. Thank you.
Everyone clear? Factory registration concept? Any doubts?
I think you already sent the presentation, but can you send it again?
This one I already shared in the first session itself.
Yeah, can you share it again? I think it's missing some.
Okay. In this
Thanks.
factory registration is not there. Huh? Okay, for factory registration, I will say okay is there. See, so whenever we register with a factory, the UVM component utils or object utils and field details, then we can able to access. In the field we have these type of sub flavors like int, if it is an integer data type, all bit byte int, short int, long int, everything will comes under integer data type. Okay, so for all those we use a UVM field int. Like that string, if you want to use for string properties to represent any characters, so then we use string. Particularly for enum data type, UVM field enum. For real data type, UVM field real. For objects, UVM field object, UVM field event. So here whatever we used, these all are int based. If you are taking string based, UVM field string, UVM field event, or enum data type. You know, enum data type, right? If you are taking any enum data type, then field enum. Okay. So in that case, whenever you took these things, registered with these, and also some more arrays for array int, array object, array string, for queues, queue int, queue object, queue string. So whenever you can take all these factory registration, you are able to access all these flags. UVM all on. That means it set all operations by default, all are on, whatever. Copy, compare, clone, print, pack, deprint, whatever, all will be on. Sometimes if you don't want to enable some compare, okay, then you need to put like this: UVM all on plus UVM no copy. Then copy will be disabled. Remaining all will be on. Okay, UVM default also, it uses all the settings, all default flag settings. It will use UVM default. So if you observe here, UVM all on. That means all methods like compare, clone, pack, print, uh, copy, all these things by default we keep as a on. We can use all those. And no copy, no compare. If you don't want to, if you want to exclude anything, then you can put like this: no copy plus no compare, no print, no deprint, no pack, like that. Okay. And verbosity levels we will get in a reporting mechanism. There we will discuss verbosity levels. That means at the time of printing, we don't use here, but at the time of printing, we give UVM medium, low, or high. Which statements will print first? Which statements have lower priority, higher priority, like that. Okay. These are most confusion topics and also need practice. Okay. So after the session, immediately I'm sharing the recorded session to everyone. So that you will be practicing more by next session, right? So that's why utilize that. Okay. And any other doubts? I will give you overall just detail. So sequence item. Sequence item is a object. So that's why we write as a object utils. And begin. Begin means here internally there are multiple number of fields. Okay. So that's why begin and we need to write. And sequence is also a object. So in sequence also we need to write a object utils. UVM object utils. Sequencer is a component. So we write UVM component utils sequencer. And driver agent, driver is also component. So component utils. Monitor is also component utils. Scoreboard is also component utils. So every time first we need to write this step, factory registration. Then only we need to move next TLM ports or phases, main functionality, whatever. Okay. This is what basic rule you need to follow for all test benches commonly. But overriding concept totally depends. Mostly we don't use in our projects because we never connect with the multiple agents, right? So whenever we connect with the multiple agent, in specific cases, only we use overriding concept. Okay. Clear till here? So that's it for today's session.
Yes, ma'am.
Any other doubts?
That problem statement you'll share today, ma'am.
Yeah, today I will share. Sheetal, Sandeep.
Prashanti, do you have some simple assignments like which can which will like clear our concept with respect to TLM or the phases or something like that? I mean, having a full-fledged UVM TV is difficult sometimes, like for the simple thing. But instead of that, maybe just writing two
Okay, today
components
I will
and the
share
test
you
bench.
one basic assignment where you will understand like only theory part. Okay.
Okay.
So another assignment with problem statements I can share.
Okay, sure.
Okay. And I will share you some other assignments also, which are useful for you for interview preparation in UVM. So you can refer those assignments. So those are very like more number of questions will be there, but whenever you got time, you can go through those questions.
Yeah, sure. Thanks.
Okay. Okay, then thank you all.
There's a session tomorrow.
Thank you, ma'am.
Sunday.
Not tomorrow. Today Thursday now. Okay. Saturday. Next session is on Saturday.
Thank you.
Okay. Yeah, thank you all.